Hello and welcome back to my basement. This is Jeremiah Wolf, and today I want to talk about this 10 gig SFP switch, the SODOLA 8x10G SFP Plus switch. It's $150 on Amazon, and I'm going to tell you right now, I think it's great. It works. It works well with some help. We'll get to that in a minute. It's built very well with one big exception. We'll get to that in a minute. But again, for the price, it's a really nice little switch. So let's take a look. There we go. So here it is. Here is the SODOLA 10 gig SFP switch. As you can see, eight ports and 150 bucks. Not too shabby. I bought their brand of SFPs for about two SR fiber SFPs. I bought three of these copper SFPs. I didn't pay that much for them. I thought I got cheaper than that. And then I bought a 2 pack of these 10 G-Tech SR SFPs. These ones specifically for my Cisco switch that the SODOLA is connecting to, and then here's the patch cables, excuse me, that I bought. I'm not going to put links in there. I'm not doing, I don't bother with referral. What are they called? Whatever. I don't mess with that. But yeah, the switch works. It works well. Let's take a look at the interface. The interface is not particularly, it's not terrible. It could be better. I saw in the reviews some people talking about returning it, saying that they were trying to set up the management and they kept losing access, and that it would only work on like the original IP and blah, blah, blah. I didn't try a DHCP, but here's the thing. If you are going to change the IP and the VLAN, you have to do it in the right order, which is you need to create the VLAN. You need to set one of the ports to be in that VLAN. Then you need to go back to your network, change the VLAN and the IP address, apply, and then you're probably going to have to go take your connection and move it to the port that you put in that VLAN. So you have to walk through the process and think it through. You're not going to be able to just change the VLAN and the IP. And I think what happens is people just don't understand how VLANs work, and whatever. Lots of features. I have no idea which ones of these fully are supported and which ones don't. The only other thing of note is if you go to, I think it's port setting. I think, yeah, okay. No, is that it? Yes. So the switch supports either 10 gig 1 gig mode or 10 gig 2.5 gig mode. You can't support all three. And once you change one interface, as I understand it, you are now changing all the interfaces. So it's an all or nothing, either 2.5 and 10 gig or 1 gig and 10 gig. So I needed 1 gig and 10 gig. Okay, so now let's talk about the huge problem with this otherwise really nice switch. And the huge problem is, holy crap, does it overheat? First off, the power supply that comes with the device, I don't even think it can power it. They gave me like this 2-watt power supply. It draws 3 watts. Just sitting, at least with the SFPs, maybe just sitting there, it's drawing like 2 watts. But once you start plugging in SFPs, especially the copper SFPs, it starts drawing power. So you're certainly going to have to buy, almost certainly, no, you will have to buy or have a bigger power supply, preferably 2 to 3 amps at 12 volts. You're need it because you need to install a fan. And that is the real problem here, is that this thing gets so freaking hot with the copper SFPs. The copper gets super hot, and I have no idea why. I don't know if this is something that other things experience, but holy crap. I mean, you can touch them, but it's very uncomfortable. We're not talking warm, we are talking hot. And the other day, while I was working, I started losing internet connection, and then it would turn off for a couple minutes, it would come back, and I think I can't. I have no idea because I don't know, but I'm pretty sure what was happening was the SFPs were overheating and shutting down. So I'm not 100% sure about that, but I'm pretty sure it gets hot. And even if they weren't shutting down, maybe some other problem, the fact that they're so hot, you're definitely degrading the life of the SFPs. So you need a solution, and here it is. You're going to have to install some fans, and so here's the switch. Give you an idea about the size of it. So it became very clear that I was going to have to put some fans in here, or a fan in here. It is fanless, and they make a big point about it being fanless. Unfortunately, it's a stupid point to make when it's overheating. It's so frustrating because otherwise this thing is it's really, I don't want to keep saying amazing, but it's really good. One of the things I really like about this is let's come in here. There's just little things. First off, this steel, it's not paper thin. You know, there's so many things you get nowadays that have a steel case that it's paper thin. You could almost punch through it with a pencil. No, look, this is tough stuff. This is very strong. And what I love these little details, these little indents right here, little punch outs in the steel. That's so you can get your screwdriver into these screws without having to struggle. What, like, it's just such a little thing, but it shows that they're thinking. And it's interesting because, you know, that is really nice. The board layout is gorgeous. I don't know who designed this board, but they did a great job. I'm not an electrical engineer, but this looks clean, looks nice, and I'm pretty sure, based on these unpopulated components, I am pretty sure that they use this very same board for other switch configurations. One thing that you'll notice, I'd like to draw your attention to, is right here and right here. They have the silk screening already there for a 2-pin JST fan connector. So I suspect that other models, they do put fans in, obviously, because they have the silk screen and they have the wiring, and they even have a little capacitor. I mean, you shouldn't need this with modern fans, but they put it there just to help the fan start up nice and smooth. So, you know, like little things like that, like whoever designed this thing was really thinking. Like, so it's nice. It's just that it gets so hot. So what did I do? So I took some measurements, and it looked like I'd be able to put two 25 millimeter fans right here. And I thought, okay, well, hopefully that's going to be good enough. So I had a couple 25 millimeter fans, and there's just another top-down view. Here's the board after I soldered on those connectors. There's my fans. And here they are installed. I first used hot glue, but the hot glue just didn't stick to the metal, which is not surprising. But I thought I'd try it. So instead I used a 2-part epoxy. Oops, sorry about that. 2-part epoxy. And then I hit it with a little hot glue right here on the board, just to give it just a little bit of help with vibration to keep the fan secure. And then I was able to route the one cable, kind of tuck it underneath, so that looked real nice. This one just tied up real well. The problem was, unfortunately, as you might imagine, the airflow is exactly this way. It goes over the chip, keeps the chip nice and cool, and then heads right out the other side. Meanwhile, there is no airflow here, which is where we wanted it. So these things are still baking hot. The fans did absolutely nothing. I thought about maybe, you know, blocking up this side of the case and sort of forcing the air down and out. But, you know, I don't know. And they were so hot. I wasn't sure these little fans would actually even work. So I was like, crap. Okay, that was a giant waste of time and effort. We need to go bigger. So here is my solution for that. I just cut a 110 millimeter hole in the top and put the screw holes for 120 millimeter case fan. I had a 110 millimeter hole saw, so that's just what I went with. Seemed to work pretty well. If I was to do this again, rather than the 120 millimeter fans, I would probably go with like 280s. Because if you can see here, you'll see it better in another picture, but I accidentally biased. I think I just got confused. I thought I was biasing the fan toward this side. Sorry, it's pretty ugly. But I actually did it over here. So here's where I have my fiber. And then 1 copper, 2 copper, 3 copper. So right now the fan is getting all of these just fine. This guy, however, is still just a smidge warm. But when I say that, I mean nothing worth even fretting about at all. Just a tiny bit warm compared to what they were, which was too hot to touch, or almost too hot to touch. It's nothing right now. So and because the way the case was built, I really wanted to, it's important to get a high static pressure fan. I'll show you the one that I got. I had several fans lying around. I tried them, and it was clear that they just were not going to be pushing enough air. So I purpose bought a high static pressure fan. And yeah, I got to say, so far it is doing great. So here's the fan installed in the top. Just put the wire, kind of did my best so it would be out of the way. And I forgot to take a picture of it together until I had it. Here we go. Back where it goes. So I just have it set on top of my OpenSense firewall, which is an old HP desktop computer. There are no feet, by the way. There's no feet. So you're probably going to want to buy a bigger power supply. You're definitely going to want to have or buy a high-speed, high-static pressure fan or 2, and you're probably going to want to buy some rubber feet. So, depending on the tools you have and what you have lying around and what you don't, this may or may not be the best deal. For me, it still works out to be a good deal. So, anyway, in addition, I also have this stuff. I bought like a pack of this years ago, and I have yet to work my way through it because it came with like 50 of these sheets of this fan mesh. And this stuff is great. If you, these 120 millimeter fans, I use them in all kinds of projects. Anything I need cooled. So I'm always using, I have a bunch of these meshes, and they work great to stop dust. It's not perfect, obviously, but they stop a lot of the dust. So really nice. And then also you might be able to tell, I put a little bit of blue thread locker on there. I just didn't want it to vibrate loose. So there's a solution. As of now, with this in place, perfectly cool. These were already cool, and now still perfectly cool. And then this one is barely warm. I hesitate to even mention it. I say so only for the sake of completeness. And as you can see, I did accidentally bias the fan toward the right side a little bit there. So maybe that's why 2 fans might be better. All right, so let's take a look at what we got here. So again, here's the switch, $150 on Amazon. Here's the SFPs. I use the SODOLA brand and the 10G Tech for the Cisco side. These are specifically made. They have different ones. You need to make sure you get the right one. These are specifically made for Cisco brand, or for Cisco to accept them. Worked fine. Here's the patch cable that I use, a couple of those. And here's the fan, Wathai 120 millimeter. I actually, when I bought this one, I bought another one because I wasn't sure what was what. And it blew my mind because complete night and day. The paper specs of the other fan was called like D Blaster or something. The paper specs beat this fan. According to the listing, it should beat this fan. It's not even close. Like, not even close. This fan, sorry the pun, but blew that other one away. Um, so pretty good. I'm thinking about buying. I don't know how long it's going to last. I'm thinking about buying another one in the next week or two, just to have one on hand in case the other thing fails. 'Cause who knows? Who knows? I don't know how long it's going to last. So there it is. The SODOLA 8-port 10 gig SFP switch. It works very well once you figure out the interface and fix the heat problem. If you're only using fiber, I don't think you're going to have the problem with heat. It seems to be 100% related to copper, and the truth is that I already had I already had a bunch of 10 gig copper stuff in place, and if I didn't, I would have bought fiber anyway. Actually, I'm not sure that's true. I might have bought copper anyway, but regardless, so just keep that in mind. If you can go copper, or excuse me, if you can go fiber, go fiber, and then you don't have to worry about it. Now, one more thing before we end, let us test. So we'll come over here. Port 5201, and we'll do 8 parallel. And there you go. 9.87, 9.85, 9.84. So we're pushing 10 gig through the switch. Unfortunately, I only have 2 devices I can test at one time. So I haven't been able to test multiple things to see like how much I can really push through the switch at one time. But frankly, for my needs, I think that's going to be more than enough. So, okay, there you go. I hope you found this informative, and I'll see you in the next one.